Hi students, so in this video I'm going to explain you how to do a U-substitution method in integration. So to do that one, before I want to remind you some rules, a logarithmic rule and some trigonometric rules. If you remember this rule that integration of 1 over x dx is ln absolute plus c. Okay, and if you have a negative sign, then you just put the negative sign. One rule is this one. Another one, integration of ex times dx is stays same, ex plus c. Okay, now some students were confused about this question, which is integration of negative 4 tan x dx. First, I will use identity on tan x. Now, the identity of tan x is tan x equals to sin x over cos x. Okay, now this question will become integration of negative 4 sin x over cos x times dx. Clear? So in this question right now 4 is a constant, so I will just put it outside of the integration sign, and now you have negative sin x over cos x times dx. Okay, so what is the U substitution method? Right now in the current expression I will see that which part of my question have derivative. What does that mean? Let's say if I will say u is equals to cos x. Okay, now let's take the derivative of u with respect to x. It's going to be du over dx, and sorry, I will take in the next step so it will be more clear. Now I will write it down. Du over dx is equals to cos x, sorry, derivative of cos x is negative sin x. Correct? Now look, what do we need? We need, I will replace these values now. The cos x will change with u, correct? So it will become 4 integration over u, correct? If I will take this dx over here, it will become du equals to negative sin x dx. Means negative sin x dx, which is right here, will change into du, will become 1 over du. Now look, this expression is related to this rule that we had in the very beginning. So what will happen? This will change into 4 and ln u is right here, and plus you will write it down c, and then substitute the value of u to your expression, and it's going to be 4 ln cos x plus c. That's the answer. Alright, now we are going to discuss this question, integration of negative cot x dx. Again, first use the identity on cot x, and the cot x identity is equals to cos x over sine x. Okay, so I will replace this expression integration of negative cos x dx into integration of negative cos x over sine x dx. Clear? Now again, we don't have a one specific formula or any integration rule to simplify or direct find the integration of this one, so we have to use U-substitution method. So again, U-substitution is going to be that part of your question which the derivative is available. I'm going to substitute u is equals to sine x. Okay, and I will also explain you why not here u is equals to cos x. Okay, so when u equals to sine x, then let's take the derivative with respect to x, and it's going to be du over dx is equals to cos x, right? And if you will rearrange this one, it's going to be du equals to cos x dx. Clear? Now cos x dx we will replace with du, so integration negative stays same, cos x dx will change into du, 1 over sine x will change into u. Okay, and we know this expression 1 over u integration is ln absolute value u, keep your negative sign, plus c. But our question is in the form of trigonometric functions, so I will substitute the u value into your expression, which is negative ln integration of sine x, then plus c. Now let me explain you why I did not use u as cos x. So look, u is equals to cos x. Okay, if I will use the derivative of this one, it's going to be du over dx equals to negative sine x, correct? And I have to rearrange this one, then du equals to negative sine x dx. Now look, you can see that sine x is in denominator in our expression and dx is in numerator, but according to this supposition they are not exactly what we want right here in our question. So that's why when we are choosing u, then you have to be really careful that the derivative is available in numerator. Okay, I hope you guys understood. I will explain you U-substitution method in more detail in the next question. So look at in this question, if you try to apply a power rule directly for this integration question, it will not be possible. I mean, it's still possible, but it's really long method. First you have to open this parentheses with the power 5 and then you simplify, then you will use the power rule. But there is a shortcut method, and that is called U-substitution method. Now again, what I was talking about, u is going to be that expression which the derivative is available. Now look right here in the parentheses, this I will consider as u. Okay, now if you will take the derivative of u right here, that will gives you the outer term, this one. Okay, so this is how you are going to decide what is going to be the u for your question. Clear? Let's do this question. So u is equals to negative 3x to the power of 5 minus 1. Let's take the derivative of this one. So it's going to be du over dx equals to negative 15x to the power of 4, and derivative of 1 is 0. Let's rearrange this expression, and it's going to be du equals to negative 15x to the power of 4 times dx. Okay, now let's uh, substitute these values. This expression which we will replace with u, and this expression we will replace with du. Clear? Now your new expression is going to be u to the power of 5 times du. Now you can see that by U-substitution method our question became very easy. Now we will use a power rule on this one, and it's going to be u to the power of 6 over 6 plus c. Now let's substitute the value of u, which is negative 3 x to the power of 5 minus 1 to the power of 6 over 6 plus c. That's it. Alright, so now we have this question, and again we will decide, first we will try to figure out if we can apply direct integration or not. So here, really complex question, we cannot apply integration directly. We will use U-substitution method. Here we are going to use u as 5x to the power of 4 plus 5. Let's take the derivative of this one with respect to x. It's going to be du over dx equals to 20 x to the power of 3, and derivative of 5 is 0. Let's rearrange this one. It's going to be du equals to 20 x to the power of 3 times dx. Now you can see this clearly, that we will replace this part with u and this part with this one. Clear? Now integration of u to the power of 2 over 3 times du. Let's take the integration of this one, and you know that whenever we take integration we add 1 in the power, and when we will add in the power it's going to be 5 over 3. So I will also just write it down this one as 5 over 3, then plus c. Now let's substitute the value of u, which is 5x to the power of 4 plus 5 over 3 plus c. That's it.